Wow. I'm going to learn how to do this on the calculator.
Really? That's kind of cool.
I just like honestly don't
That's cool.
Notes.
And someone was like, I didn't know what happened.
Love notes brings me so much joy.
Okay, we have been working with linear equalities, linear inequalities, absolute value equalities, absolute value inequalities, and we've been doing all of this in one dimension on the number line.
2 dimensions.
Today, we're stepping it up. We're going to be working in 2D. So we're going to be solving linear inequalities, and we are going to be graphing lines and shading half planes. So we are going to need straight edges. We may want colors eventually. I mean, I don't know. I like my graphs to be pretty. So we're doing a quick recap before we generalize to 2 dimensions. So, as you may see on the PSAT or the SAT or subject test, they may give you an equation, they may give you an inequality, and they may ask which of the following is a solution. How would you determine which of the options is a solution? What would you do?
You graph it, look at it.
Okay.
Solve.
Okay.
Substitute.
Yes.
Okay.
You would take those solutions and you would reverse engineer the problem. You would just substitute in those values into the original problem and say, which makes a true statement? There's your solution. So keep that in mind as a problem-solving strategy. So let's say you have been given -2 is greater than or equal to x. Perhaps, best practice is that we rewrite this with the variable on the left. So x is less than or equal to -2. These are the same thing. If I wanted to graph the solution set, what is happening at -2 on the number line? Closed circle and shading to the left. Again, if you solve for the variable on the left, you shade the direction the inequality is pointing. Now, is -2 a solution to this?
Yes.
Yes, it is. It is shaded. Is -10.5 a solution?
Yes.
Yes, it would be shaded if I kept going. Is 0 a solution?
No.
No, it is not part of the solution set. But how would I represent this graph as an interval?
Close -2.
I love it.
Wait.
Now, I may give you the symbols. I may give you words. So we have to be able to translate those words into those inequalities. Well, the less than symbol could mean fewer than. I have fewer than this number. Greater than symbol could be I have more than that. I mean, it makes sense. Less than or equal to, that means I have at most, no more than, at most. If it's greater than or equal to, I have at least that amount. No less than that amount. I can have that amount, but no less. So what if you have been given this scenario, and you're asked to, assign a variable to the unknown and represent the scenario as an inequality? Yesterday you went and exercised. You ran for 20 minutes. You biked for more than the time that you ran. So we know how the least I could have run, right? Because I ran 20 or biked, and I biked more than that. So if I say, all right, let B, I don't care what variable you use, I'm using B for bike. Let B equal the time biked. How would I represent that as an inequality? B is
More than 20.
okay, greater than 20, yes. So again, I'd like to see 0 when we graph it. I'm going to count by 5, 10, 15, 20. Open circle at 20, shading to the right. Okay, and the next one, to order from a child's menu, you must be at most 12 years old. No more than that. You're over than 12, you're not ordering from the kids' menu. So here it's saying at most 12 years old. That could be less than that. We want to graph an inequality that represents the age you can be to order from the kids menu. So I'm going to say let A be the age to order from kids menu. And so A would be what?
Less than or equal to 12 years old.
Beautiful. So again, I like to see 0. I don't care what you count by. 2, 4, 6, 8, 10. Yes.
For a question like this, we would have to put that it has to be greater than 0.
Technically, as we start working these problems more in 2 dimensions, yes, it would have to be non-zero. So more than likely, we're going to be restricting a lot of the stuff we do as far as linear programming and optimization to the first quadrant, because time and every is going to be positive. So do you have to for these right now? No, because all I'm doing is representing the situation. But yes, I love that you're thinking that way, because that's where we're going. That is where we're going. Now, here we had some rules when we were solving inequalities. If I were to solve for x in the first one, what do I do?
You have to swap the sign by dividing by
Okay,
negative
I'm
5.
going to divide by a negative 5, which means I have to change the direction of that inequality. So that's going to give me x is less than negative 9. So I do have to change the direction of the inequality. Again, I like to see 0. I don't care what you count by. Let's say 3, negative 3, negative 6, negative 9, open circle, shading to the left. This is nothing new. This is just a quick primer for your little brain before we move to 2 dimensions.
Little brain.
Yeah, you got a little brain.
Okay.
There's so much more math out there.
Your prefrontal cortex is not developed.
Thank you.
Okay.
Yeah, you don't even know how to do matrices. Little brain. Solve for x in the next one.
Mine's 7.
Okay. So I have 2 is less than or equal to x if we like the variable on the right-hand side. I like it. And then I'm going to say, all right, I'm going to show 0, 1, 2, close circle at 2, this shading to the right. Next one, what am I going to do to solve for?
Multiply by 4.
Okay, multiply both sides by 4. Okay, that's going to give me x is less than 20. Again, let's show me 0. I don't care what you count by. 5, 10, 15, 20. Open circle 20, shading to the left. You should be able to do these this quickly. These are not hard. Next one. How on earth am I going to solve for x?
Multiply by negative 4.
Third.
Oh,
Yeah, you can do it in multiple steps, but you might as well just
yeah,
It's
yeah.
negative.
multiply by the reciprocal, make that a 1.
Yes.
So I'm going to have x is what?
Less.
Less than 12, right? I changed the direction of inequality because I multiplied by a negative across the inequality. Show me 0, don't care what you count by. 3, 6, 9, and 12. Open circle at 12, shading to the left. Okay, now, we have some more scenarios. We're going to have to answer some questions. You need to make at least 150 sandwiches. At least. You can make more. You can't make any less. You got to make at least 150 sandwiches. Now, you've already made 25. Yay for you. We want to write an inequality to solve for the possible remaining number of sandwiches you have left to make. Define a variable. So I'm going to go ahead and let S be number of sandwiches to make. So how would I represent that inequality? S, what?
Minus.
S
Plus
is greater than or
25.
equal to.
Well, S
Plus 20.
plus the 25 I've already
Yeah.
made has to be
Greater than or equal to 100.
excellent. So that would be the corresponding inequality. Could I put the 25 on the right? Yes. But I'm just showing that I have to make something. I've already made 25. The sum, the total has to be greater than or equal to 150. So if I were to solve this so I could graph the solution set on a number line, it would be S is greater than or equal to 125. This is a word problem, so you would answer it in words. You would say, oh, I need to make at least 125 sandwiches. Show me 0. I don't care what you count by. I'm counting by 25, 25, 50, 75, 100, 25, 50. Ooh, I'm way too far. 25, 50, 75, 100, 125. Closer. Shaped. Now, next example. You go to the grocery store. You want to buy some bananas. You have $18. You only have $18. Every banana, each banana costs $1.50. You want to know how many bananas you can buy with that $18. So we define a variable. Let B be the number of bananas by. How you word that exactly, I don't care, but I need to have a variable and what it's representing. So how would I represent this inequality?
18 is greater than or equal to 1.5 times B.
Yes, and I'm going to write it where it actually says that I can't spend more than $18, but it's the same thing. It's equivalent. You just put 18 on the left. So $1.50 for every banana.
Oh, hold on.
I can't spend more than $18, so I'm dividing by 1.5, and I get B to be less than or equal to. I can only buy 12 bananas. 2, 4, 6, 8, 10, and 12. I can buy 12, or I can buy less and save some money. Something else.
Would it be wrong if you just said like B is less than or greater, or is equal to or less than 18 over 1.5?
Simplify. That can be reduced.
Yeah.
Simplify. It's equivalent.
Yeah.
It's not simplifying. You ready for 2D?
Mm-hmm.
All right. 2D. Back on the Cartesian plane. Now, what's important is that we are graphing lines, but since we don't have equalities, we have inequalities, we need to know what that boundary line is going to look like. In other words, if I have a less than or a greater than, my boundary line is going to be dotted or dashed. If I have an inequality that has a less than or equal to, greater than or equal to, my boundary line is going to be solid. Once I determine my boundary line, which I can graph once I put it in slope-intercept form, it's real easy. Y-intercept, rise and run the slope, boundary line. Then I have to figure out which side of it's shade. That's not hard either. So the first thing you're going to want to do is put it in slope-intercept form. If I'm putting this in slope-intercept form, I'm subtracting x from both sides. And I'm getting y is less than negative x plus 2. So this is the inequality that I am ultimately going to graph.
Can you zoom in possibly or like turn the light on or something?
Oops, I went the wrong way.
Is that better?
Perfect.
Okay. So tell me, what is the y-intercept? Oh, y'all are pitiful.
0, 2.
It is a point. 0, 2. Really, by now, I figured. Yeah, I mean, we're talking mid-October. We should be a little bit
I only made that mistake
less sloppy. Okay, 0, 2. From there, I'm rising and running the slope, which is what?
Negative.
Negative 1. So from here, where am I going? Down 1 and to the right 1. Okay, so I'm getting ready to graph my boundary line. Before I graph my boundary line, I see that I have a less than symbol. So tell me about my boundary line. Is it solid or dotted?
Dotted.
It is a dotted. boundary line. Okay, so from here, I'm going to go ahead and graph with dots or dashes. Just don't make it solid. Okay, so there's my boundary line. My next step is to figure out which side of the half plane, which half plane am I shading? Am I shading this half plane? It's called a half plane, even though it goes on forever. We're cutting it technically in half. Or am I shading this side? Well, one nice way to do it is to pick a test point. Pick an x and a y value, substitute back into your original inequality, and see if that point gives you a true statement. If it gives you a true statement, you shade the half plane that has that point. If it gives you a false statement, don't even think about shading that point. Now, what point do I like to use? I like to use the origin. Unless my boundary line passes through the origin. If my boundary line passes through the origin, well, don't choose it. Choose something else. So if I choose 0, 0, and I substitute it into this inequality, 0 plus 0 is less than 2. Is this a true statement?
Yes.
Yes.
This is a true statement. So then the point 0, 0 is going to be shaded. So that means I am shading this half plane. Let's try another one. I have a linear inequality in 2 variables. I need to put it in slope-intercept form. I'm going to subtract 2x from both sides. I'm going to get negative 3y is greater than or equal to negative 2x plus 6.
Scroll down.
Tell me the next step. Divide every term by negative 3. Ooh, divided by negative 3. What do I have to do? Change the direction of the inequality. So I have y is less than or equal to 2/3 x minus 2. There's the inequality, slope-intercept form. Let's graph it. What is my y-intercept?
0, -2.
Thank you for giving to me as a point. 0, -2. From there, I'm going to rise and run my slope, which is 2/3. So here I'm going to go up 2 and to the right 3. I'm looking at my inequality, and I'm trying to decide what my boundary line is going to look like. What is my boundary line going to look like?
Solid.
It is going to be a solid boundary. So I connect my 2 points and I have my line. It's a solid boundary line. All I have left to do is to determine which half plane am I shading. So let's choose a test point. What point do you want to use?
0.
Sure. I'm going to substitute back into the original inequality and see, do I get a true or false statement? It is false. So don't you even think about shading the region that has that point that did not work.
Isn't the shaded part just like always like whatever y is compared to, like, for example, y was less than 2/3 x minus 2, so does that mean it just always goes on middle line?
Yes, it does. You have just generalized our conclusions on the next page.
Wow.
I love it.
Good job.
I love when I lead you and you go right where I want you to go. I love it.
What did he say? I got to figure
It's
it
a
out.
shortcut.
Yeah,
It's
I
a
got to
shortcut.
figure it out.
All right, you can graph inequalities in the form, slope-intercept form. Y is greater than or equal to mx plus b. Y is less than or equal to. I mean, equal to is irrelevant at this point. The point is, if you isolate the y, put it in slope-intercept form. By looking at the inequality, you know which direction to shade. So if it's greater than, y is greater than mx plus b, I'm going to shade up the boundary line. If I have it in slope-intercept form and it's less than, I'm going to shade below the boundary line. Now, if you can't remember that, pick test point. It always works, unless you do your math wrong. In which case, well, we have bigger problems. Now, what if I have a special line, vertical line, horizontal line, changes things a little bit. If I have a vertical line represented in the form x equal a number, I'm not shading above or below anything. However, if I isolate the x on the left, if I have greater than, which direction do you think I'm going to shade from the boundary line? To the right. And if I have less than, I'm going to shade to the left of the boundary line. Common sense. Yeah. Now, if I'm dealing with a horizontal line, y equaling a number, isolate the y on the left. If I have y is greater than b, I'm going to shade above the boundary line. And if y is less than b, I'm going to shade below the boundary line. So let's look at a few examples. Y is less than or equal to -3. First, tell me something about the boundary line.
Solid.
It is a solid, what kind of line? Horizontal boundary line.
Can you scroll down?
Yes. So I'm going to go to y equal -3, and I'm going to draw a solid horizontal line. And then since it's less than, I am going to shade which direction? Below. Don't forget to label your axes. Now, what can you tell me about the boundary line for the next example? It is a vertical boundary line. And what else can you tell me? It is a dotted or dashed boundary, vertical boundary line. Okay, so I'm going to go to x equal 2. I'm going to draw a dotted boundary line. Since x is going to be any number that is greater than 2, which direction am I shading? To the right. Now, let's talk about this one. Walter found a used bookstore, and it sells pre-owned videos, and it sells CDs. More information, the videos cost $9 each. The CDs cost $3 each. I'm gaining some information. Now, Walter can spend no more, so less than or equal to, right? He could spend $36, but no more than that. We want to define variables, represent the inequality, solve the inequality, and show the solution set, answer some questions. So I'm defining some variables. So I'm going to let, and I don't care what you use, x, y. In this case, I see videos. So let v equal the number of videos to buy. And then I like to add any additional information right then and there. I know they cost $9 each. I also have CDs, so I'm going to let C equal the number of CDs to buy. And I also know that they cost $3 each.
Do you have to say the let, or can you just say B equals C?
Well, we kind of like what? Let is.
Okay.
Now, I'm gearing you up to a project that you are going to get for optimization and linear programming, where you're going to have to write a beautiful, cohesive, mathematically elegant write-up for a solution with lots of so it will be really let. All right, inequality. I want to know how I can represent how many of each of these videos and CDs I can buy when I only have $36 to spend. Anybody? Any ideas?
You could.
9V
I like it. 9B
plus 3C
plus $3 for every CD.
is less than or equal to 36.
Fantastic. Any questions on how to arrive at that inequality? Okay, now, I chose V and C. If I'm graphing it on the Cartesian plane, which we know to be x, which is V and which is C?
It
really doesn't, as long as you label your axes correctly. Now, if I told you he has to buy 2 CDs, then the number of videos he buys is a function of the number of CDs. That changes that. I'm not going to do that to you right now. Okay? But we are going to label our axes. So I'm going to, right now. Little brain. When we have a little bit bigger brain, maybe. Okay, so I'm letting V be my horizontal, my independent variable. I'm letting C be my dependent variable, my output. So that means I need to solve this inequality for what variable to be able to graph it the way we normally do.
C.
I need to solve for C. So I'm going to subtract 9V from both sides, which is going to give me 3C is less than or equal to negative 9V plus 36. Then, beautiful. Divide every term by 3. So C is less than or equal to negative 3V plus 12. There is the inequality. What can you tell me about that inequality? I'm sorry? The boundary is solid. Yes, it is a solid boundary line. Excellent. What else can you tell me? Okay, I'm going to shade below. I want to start graphing. What do I do? Which is?
12.
0, 12. Okay, I'm going to count by 1, 2, 3. It's up here. So there's 12. And then?
Go down 3.
Down 3. And run?
1.
Solid boundary line, less graph. Solid boundary line, shading below, and I'm restricting it, Cameron, to the first quadrant because, you know I can't have negative CDs, I can't have negative money, I can't have negative videos. So I am restricting it to that first quadrant. Now, we want to describe what the intercepts represent. So the C-intercept represents what in this situation? The number of CDs to buy when? If, be more specific, that's not enough.
If you buy no video.
If you buy no videos, right?
Yeah.
Because when V is 0,
Right.
I'm at 12 on C. Okay, so let's keep going. So then what does the V-intercept represent? Right, the number of videos to buy if no CDs are bought. Good. So that would be there. Now my question to you is, does Walter have enough money to buy 2 videos and 3 CDs? How do you know? 2.3, 2 comma 3, 2, 3 is in the shaded region. A solution is in shaded region. Right?
Mm-hmm.
Now, does Walter have enough money to buy 4 videos and 5 CDs? No. No. Not in solution set.
Can you scroll down?
Yes. So if I were to ask you to state 2 combinations of numbers of videos and CDs that Walter can buy, given that he only has $36, how could you go about giving me those combinations?
Choose 2 B's and C's that are within the shaded portion.
Beautiful. I don't care which ones. I could say, I could buy nothing and just keep $36. Or I could buy one and 1 video and 3 CD. It doesn't matter. Whatever's in the shaded region works. Now let's talk about how we're going to graph inequalities on the calculator.
Oh yeah.
I'm going to go back to this example.
Mine can't do it anymore.
Okay.
Piecewise functions. Oh.
These are just linear functions. Highest degree of x is 1, so I know it's a line. Okay, to graph a line, we know we go to y equals. Or to graph any function of x, we go to y equals. Now, I'm going to go ahead and put it in as the equality. Negative, make sure you use a negative, not a minus sign. Negative x plus 2. Okay, if I were to graph it as is, it would be the line y equals negative x plus 2. I don't want the line. I want this inequality, so I have to somehow show a less than symbol. How am I going to show a less than symbol? I'm going to scroll all the way to the left. See that part flashing?
Yeah.
Hit enter.
Ooh.
And you can choose open circles, dots, tiny dots, lines, thicker lines, greater than, above,
How do you choose?
less than, below. I hit enter, I hit
Yeah.
OK, I graph the line,
It's not working.
or the inequality. So in this case, I have,
What page?
Huh?
What page?
I'm just graphing number 10,
Yeah, how do
the
you
example we did a while back. Now, remember, if you don't see anything or if you don't see something that you like, you might want to change your window, right? Because we may have
Which one do
adjusted
we
our
want?
window.
Hang on. Wait, this is the sign that you want, though.
what
Okay, so
Hold on.
How do you get to
Okay, we're doing this one. Hold on. It's not this one.
the... Okay, so go to y equals and then go to the left and hit enter.
Oh, it's the left. It's the other one.
Yeah, it's that. Yeah. Now graph.
Are we there?
There it is. My scatter plot.
Do we have a beautiful linear inequality shaded? Cameron says
It's
yes.
not as great as yours.
Yeah.
Yes,
Yours is
yes, good. So, to help you practice solving and graphing linear inequalities, you know I got practice.
Yay.
You can put, once you get all of these in, oh, did I give them to you? Oh, no, I didn't. Only some of them. Put them in slope-intercept form, graph them, identify intercept, slope, solid, dot, you know, those are all good things to be able to explain. Answer keys in the back, you can always check them by putting them in your calculator, right? So you graph, is the slope on the right? Yes? So, you have practice. Your tests are still back there if you want to look at those again, spend some quality time with those, make sure you understand what you missed. You have my math lab. We're done. We're not learning anything new tomorrow. Instead, what we're doing is some review activities. Because we got a quiz next week, right? Yes. So we're prepared.